Hey everyone. So I'm from Tartu University. I'm a professor. And my plan is to talk about several things. First of all, I'll introduce my organization to you, which is Tartu NLP. Then I will briefly talk about ChatGPT or large language models overall. And I will definitely talk about Estonian languages, and I'll try to explain why that's in plural, not just one Estonian language. What does a university do at an event like this? Of course, the university wants to assert itself as useful. Naturally, a university is a source of IT students and specialists who later maybe hopefully defend their theses and then go off to work in a company. Sometimes they don't wait for it, and sometimes they never defend, and let's not let that happen. Well, besides that, of course, as a whole institute of computer science, we still have the feeling that, well, there are these companies doing useful stuff. We want to be useful as well. We don't just want to be teachers or lecturers and researchers. We want to do useful stuff. So I guess I'm, in my head, as a member of the university, I have a clear answer that we are useful and so on. I guess I'm too afraid of the results to ask you for a poll of show of hands who thinks their education was useful or not. Maybe some companies just get people inside, so I'm not asking for a poll. Let's just assume that universities are very useful. I can at least speak for my own area, which is natural language processing or language technology, that in 2015, when I came back from my postdoc, there was a whole generally accepted belief that this is a soft science area, really not interesting for computer scientists. This is more linguistics. And I've been trying my hardest to prove this otherwise. And I don't know what happened, but 8 years have passed, and now suddenly this area is very popular. Maybe OpenAI had something to do with it. Maybe neural networks back in 2015. So anyway, but coming back to the role of the university as actually, so we don't want to just teach. We don't want to just publish papers and leave the impression that we only teach and publish papers. What happens when a university actually wants to be useful? The situation is quite, so the stereotypical way how this goes is that, well, the university researchers want to show that they are capable of doing something really practically useful. Number one. Number two, what they do is they launch a spin-off company based on their research where they develop the practical stuff. And as a result, the public opinion is that all practical results come from private companies and not universities. So even though this is a viable scheme to do useful things in certain scenarios, I personally, so I'm a member of the Computer Science Institute, I'm heading the chair of NLP, and to fight against this current, what we're doing is we are calling our chair, which, I mean, the full name is the University of Tartu Institute of Computer Science's chair of natural language processing. Instead, we say we're tartunlp.ai. It is a URL you can go. This is our homepage. So we kind of pretend or have this front end of looking startup-y, being startup-y, without actually being one. So it has its own benefits and drawbacks. So there's no exit, but you can invest into us. So please invest into us. No, actually, I mean, what we do is actually we, besides teaching and research and so on, we do collaborations with companies, and we do open source solutions for, so AI for NLP. In Estonian, there's a word kratit, used very actively by the Ministry of Ministry of Economics and Communication, which are like little AI helpers. We do those, so we have a translation engine, we have a speech synthesis engine, we have a bunch of others, and we have online demos which you can actually check out or for yourself. They are all open source, they can be downloaded as models, they can be used through an API, so we're not yet complaining of being too popular so that we have to limit access to this API. Prove me wrong. I hope to reach the point where we have to start limiting our APIs. Another thing we're doing is R&D as a service. So we collaborate with companies and we do things that companies don't know or don't want to focus on. So we don't do development. For development, there are huge companies with developers. We try to figure out what are the best solutions for tasks nobody else has tackled, or those companies have not tackled. So take some custom data, figure out what to do with them. And we've had a number of collaborations in different forms. We have had a Horizon Europe project with Mozilla. We have done governmental tenders with Tilde and crawling into bed with Cybernetica. We've done direct service offering collaborations to the largest Estonian translation bureau, Luisa. Same thing for the web hosting provider Elk-Data or veebimajutus.ee. And we, of course, do research and applied research and developing of resources and solutions for Estonian as well as Finno-Ugric language NLP. And as for Kratit, I don't know why I put the URL down there. So there is a Koodivaramu, so the state code repository where you can actually find our little AI helpers. So this is us. Now, that much about Tartu NLP. Next item on my agenda was ChatGPT. So where are we as humanity, as the world, in terms of AI? We had a very nice show introduction in the morning with the dancing lady and the robot and so on. Let me try to sort of redo that. How was AI or anything AI resembling done in the 60s? So with rules or logic? There, the human engineer or developer or scientist has to pretend that they know how things are done. They have to pretend that they know how language works, even though we don't know until now. But the coding would go like we explain to the computer by writing a program what to do, how to do, which keywords in which order, which components have to be done in which way. So everything is written out as code. Basically, we have to know the algorithm. The problem with those is that, well, we don't know the algorithm behind language, behind image processing, behind all kinds of other data-driven things. And then the computer had a pretty passive role because you have an interpreter or compiler which just does what we do. Now, in the 90s or so, give or take, statistical methods have become quite popular, 90s, 2000s, and so on. And then the approach can be described by, so we as engineers do, well, here are the features we've extracted from the data, and here is the data itself. And here is how you put the components together. So here is the computational graph. And since we're talking about classical machine learning or statistics, then now go and learn each component. Maximum likelihood estimation or so on. You've learned each component. We've manually defined in which order and how exactly those go together. And the role of the computer is now, well, still quite passive, but still the contents of each component are learned automatically. So the computer already has some say in what is being done. Come 2013, 15, 16, depending on the area, the age of end-to-end neural networks. We as engineers, we are still communicating to the computer using data and using programming languages or using some instructions. What we do, however, so the essence of what we do is here's the data, and no features have to be extracted. So it's end-to-end neural nets, it's raw input, raw output. Here's the data, here's the computational graph. Now just figure out the whole scenario. Just go and learn it. There will be, we still define how, in which order this is done, which kind of vector space transformations are being done, but all of it is learned end-to-end in one go. And the results are pretty cool. And the results are much better than classical machine learning for scenarios where you have enough data and so on and so on. But several tasks show that so this works better there. The result is that it works cool and that this kind of methodology we use gives us black boxes where it works nicely, but we don't know why. And when they do get what is nowadays called emergent abilities, or some internal representations are not just useful for this neural net, but elsewhere, we have no idea why, and we have no idea how reliable this is, and so this remains a black box, which is why I wrote there, hey, very nice, wait, how did you also do that part or do that part? So, but still, the final performance is cool, and the black box ain't saying, but this is what the world sticks with. Come 2023, we have large language models. So this is nowadays. What we do is we don't need the specific data, the extraction of features. We don't need to speak Python or brainfuck or assembler or any other programming language. We need to know English. And what we say is, well, we just describe the task in English or Estonian or some other languages, and we have to say please, or say in some way, and please, or just express this in this and that way, and this also has to include this, or this also has to conform to that. And then, I'm not religious, but basically then you pray. Because it's unreliable, and it says, well, yeah, sure, maybe, maybe not. It's unreliable. It can do the task, and it can wow us with its performance, or it can just hallucinate and not do the task. Or lately the models can say, no, asking for this information is ethically unacceptable and I will not do it, even though you disagree with the model. How do we continue this picture? I mean, it's 2023 now. If we extend this tendency, where the computer every time has more autonomous behavior and takes more and more control, it's in the future, so it can continue in many ways. But one likely way that it might end up with is that the computer says, I'm going to do this. And then the engineer says, OK. Just like we were in the reverse roles in the beginning. Maybe not. Maybe, well, future will tell. Now it's hard to place us. We are either in the age of large language models because, well, those are available, or actually, if we look at things companies do, then I think it's very reasonable to do a couple of rules if you are facing an easy problem and you need it solved quickly enough, and that gets you a reasonable enough solution. It doesn't need to be in the 60s, it can be done now. And if that doesn't work, you go with a linear model, and if that doesn't work, only then you go for a nonlinear model, and only when that fails, you go for neural nets or large language models and so on. So you have to have a good reason to use this. So all of these methods exist now. They're not gone from the 60s, they exist, but overall as a state of AI, so I think this is where we are. So language models, the large language models, including ChatGPT or GPT-4 or all the other ones, they have been discussed in several talks today, and they have received their unfair share of attention over the past, months. Their benefits, of course, are, well, first of all, I mean, I'm going to complain about them for the rest of the talk. So to give them their due diligence, I mean, they're awesome. They talk. You can talk to them. None of the previous methods allowed you to actually talk and give an intelligible, or receive an intelligible, this is a bad word to confuse, intelligible answer. So this is the first time we can actually have an open domain dialogue with computers, even though they sometimes, are unreliable. But these are the minuses, not the pluses. The pluses are that they talk, and it's awesome. Secondly, they are quite flexible, and they follow and they understand the context of everything you've written or given as a prompt. And this is a big problem for previous methods, including end-to-end neural nets, because there you have to agree that you're processing, well, some data instance in, data instance out. The data instances are RID, so independent and identically distributed, and you just have to focus on them. If we focus on NLP, then these typically are sentences. If you want to do something on a document level, resolve an anaphora or understand references between sentences, it's a huge problem. It's not a problem for LLMs. They just read the whole doc, and they produce output. Of course, we are sacrificing the structured output. So we used to train models that would give us exactly what we would ask them for, so either structured output or text output. Here, we just ask nicely, and we hope that the output will be in the format that we want it to be, and it might or it might not be. So, that's of course a big problem, but still, we sacrifice that, and what we get is the flexibility and the emergent abilities. What was just recently called zero-shot performance or so on, now it's the tasks that we didn't specifically teach to the language models, but they solve anyway, like write a poem about the contents of the Digit conference using pirate speak. I be at a conference in that style. So they not only speak natural languages and can generate programming languages, but they can imitate different styles. Let's say Harlem English or pirate speak, or there were letters circulating, I think, to Mart Helme written in Võro. So I think it takes a lot of attempts to generate coherent Võro, and I wouldn't be the one to tell the difference, I don't speak it, but still, at some point they managed to generate it. Now they just say that this is a too low resource language and we cannot reliably generate, so it's getting safer but more boring. But still, they have these awesome features. Their minuses are, of course, that to train an LLM, you need huge data sets. It's even bigger, so the requirement for the data is even bigger than for the end-to-end neural nets, which were already data greedy. Thankfully, they only need unstructured, unannotated text, and then later instructions, and then later safety concerns, so it gets more complicated. But still, the pre-training only needs raw text from the internet, no annotation, no info, no translations, no structurization of the text or anything. And of course, even when you do have huge data, and even if you focus on the high resource language like English, German, French, or Spanish, those models still hallucinate. So you might ask something where they very confidently reply, and they just give you some complete nonsense answer. So these are the hallucinations. But still, they're very awesome. And it's, of course, not just the OpenAI models. There's a plethora of them. So this Viktor Garske has a very nice graph of the development of the foundation models, including the text large language models and others. It's available at this URL there. Here, it all began with the paper that introduced transformers. So the attention is all you need by Vaswani and others in 2017 at NeurIPS. And then from that, it reaches up to DALI 2 and now 3, up to GPT-4, up to all kinds of papers of emergent abilities or sparks of AGI and so on. So quite useful. And on the right, you see a link to the Hugging Face open large language model leaderboard, where you also can look at all of the llamas, vicunus, falcons, and other models, open assistants, MPT, and so on, which exist, which have been trained. That much about language models. We are in Estonia. What is the status of Estonian in those language models? The features we want for a perfect large language model for written Estonian, so let's talk about Estonian in singular so far. We want it to be a modern, contemporary, and high-performance model, like GPT-4, like Llama 2, like so the ones developed now, not 5 years ago. We want it to be truly open, usable for commercial purposes, and usable, downloadable through Hugging Face, and so on. So if it's not realistic, then, you know, a girl can dream. Still, this is something we really need to continue developing, for example, open source software for the government, or for everybody to use. And of course, we want it to support Estonian on a good level. And the current state is that you have to choose 2 of them. Of those 3 properties, you can choose 2 and not get the 3rd one. I'm showing it on a picture here. So we have the yellow, the contemporary and high-performance things, like GPT-4 and GPT 3.5 speak quite good Estonian and understand quite good Estonian. Llama 2, Falcon, MPT, and so on, they're purely English. They have a tiny fraction of data in Estonian, and they don't know Estonian. But the yellow oval, the yellow ellipse there, is for models that are contemporary and high-performance. That doesn't include the Estonian models. The Estonian open models include XGLM, which is 3 years old, I think. So the cross-lingual generative language model. There's the one we developed at the University of Tartu less than 2 years ago. It was a clickbait name for, so GPT-4 didn't exist then, and of course I called it GPT-4 Estonian. But so that one is tiny and old, and I mean it generates text, but it doesn't talk, it doesn't speak, it doesn't have the emergent abilities. I think it has 1-point-something billion parameters, so compare this to the nowadays models. Right, and so we have GPT and XGLM doing the Estonian thing, but they're not contemporary, and they either perform badly or are closed models. And then there are the Llama and Falcon others, which don't know Estonian at all. This is quite upsetting. And I mean, here are some examples for those who do speak Estonian. If you ask, and this was generated on, so I was supposed to deliver the slides by Thursday, so I delivered them by Tuesday. And this is an example from Monday. Very fresh, 3 days ago. You ask how many cases are there in Estonian. First of all, it makes a grammatical error in the second sentence, need käänet, not supposed to be candid. And then it lists the cases in Estonian. It at least gets the number correctly. It used to say there are two, the big one and the small one. Then it got better. And then first it looks fine. Nimetav, omastav, osastav, nominative, genitive, partitive. Then there's siht, ütlev, doesn't exist. Sis, ütlev, that doesn't even sound like Estonian. Then number 6 is seest, ütlev, which is fine, elative. And then number 12 is also elative. So the language is slightly broken and the info is quite broken. But overall, I should not complain. I mean, I asked something in Estonian and it responded in Estonian. Compared to what we had before, this is a huge progress. But of course, we are unsatisfiable and we want something as good as the models that we have for English. Why? Well, because it's not just English. Like if you ask in German, wie viele Kasus gibt es in Deutsch, then there are no errors there. Neither content, nor grammar. And I'm not talking about Latvian. Of course, Latvian will have errors. But so the bigger languages, they are fine. And this is upsetting because the situation with Estonian NLP is quite all right. There exists the National Program of Estonian Language Technology, so Riiklik Eesti Keele Tehnoloogia Programm by the Ministry of Education and Research, which funds all kinds of applied and research projects. The Ministry of Communications and Economics developed their bureaucrat, so the AI helpers, the chatbot that would connect you easily to governmental services, and they invest millions in it. Then there are several research groups who actively do NLP, like us, like Taltech, like the Tallinn University, like the Estonian, so the Institute of Estonian Language, and others. And there are companies, big and small, doing open source or closed source, but still working on AI and NLP. And this slide was too narrow to list all of them, but I mean, a lot of you are here actually. So this is upsetting. I mean, that Estonian NLP is doing fine and we don't have an Estonian LLM. Now comes the part where I explain why I used plural on Estonian languages. If you look at the typology of the languages, then Finnic languages get split into coastal Finnic and inland Finnic. And inland Finnic is where the South Estonian came from, Võro and Seto. Those are the live ones. They also include Mulgi and Tartu. And then the other branch includes Finnish, Estonian, and then the lower resource languages like Karelian, Vepsvotic, and Livonian, which is, strictly speaking, extinct and otherwise, well, critically endangered. So it's not, I mean, governmentally or administratively, it's defined that Võro and Seto are dialects of Estonian, whereas linguistically, they're clearly an example of a separate language. They might be dialects of each other, but their own national identity is strong enough so that we would split, just like we split Serbians and Croatians, we can, in the same way, for the same reasons, split Võro and Seto into two different languages. Not only those, but Estonia has very many different dialects, like Mulgi, like the island dialects different in each island, and then the rannakeel in the north there, which is even more similar to Finnish than to Estonian, they say, but I don't speak it, unfortunately. Some of those are extinct. I mean, if you see this map, some of those, like almost nobody speaks Tartu, the dialect. Although if you go to Tartu, then like in Tallinn, you don't make a difference between this and that. See ja see seal. In Tartu, you would say see ja too. See asi siin, too asi seal. So there are some differences which still thrive. Võro and Seto are actively spoken languages. There are ABC books in Võro. There is a kindergarten where kids speak Seto, and there is a whole island of Kihnu, which has something like several hundred people talking Kihnu Estonian to each other. So, and they have several books published in Kihnu. So the written Estonian should be abits with an I, and this is abets. If you read this, you can rattle your brain and understand it, not with those pixels though, but still, I mean, for the purpose of existing data and speakers of that language, it's a separate language. It might be linguistically a dialect of the Northern Estonian, but at least in my opinion, it's enough to know that there are some people who speak some version of the language, for that language or dialect or version to have a right for existence and also to have a right to be supported by NLP tools like the large language models. Because there are people who use those languages as their mother tongue. Just like we don't want the models that are being created today just to know English, we want to teach them Estonian, we also would very much enjoy teaching them all the other Estonians that exist, if it's possible. Let's spend the rest of the talk talking about whether that's possible. We haven't yet gotten around to the dialects, but we have worked for 2 years with other Finno-Ugric languages. The situation with the amount of data there is, so textual data for those languages, is shown here on log scale. So in the horizontal axis, you have the number of speakers, approximately per language. I mean, it's really hard to estimate. And then the vertical one is for the number of tokens in the data that, well, we managed to collect. It might be slightly different, but the scale of things is similar. So those are not all of the Finno-Ugric languages, but those are, I think, 23 Finno-Ugric languages that we managed to cover in our work so far. And you see Estonian, Finnish, and Hungarian up there. So they have over 1 million speakers, and they have then at least tens or hundreds of millions of tokens. If you look at other languages like Livonian or Hanti and Mansi, then they are in very differently bad situations. Livonian has 20 active speakers, and those aren't even native speakers. Those are the ones who learned it on a near native level, but the last native one died in 2013. But they actively collect the data, so there is about 50,000 tokens of monolingual data that is easily digitizable without, processing speech or written manuscripts. On the other scale is the Hanti language, which is an Ugric language, more similar to Hungarian, where there are much more speakers. So the number I found was 14,000, but the data that could be collected is really, really, really tiny. But there are people speaking it. There is, even if their people are dead, then it always makes sense to extract the data that exists for a dead language and still preserve it in the digital form. So, how do we go about creating large language models or any NLP support for any languages like this? I mean, we have done translation. So if you go to Translate UTEE, you can translate. I mean, we have some results are worse, some are better, but we can translate into Võro, into Livonian, into, as you see here, the long list of languages. But this is the, the previous one, end-to-end neural nets for just translating. The holy grail is, of course, getting a language model to talk, because then you can talk to it, then that can teach you the language and, all other emergent abilities. What is the status of, developing large language models? There's the Chinchilla paper, which defines the ratio between the number of parameters of the model and the number of available tokens. So that tells you how high up can you scale the model. So if you have 20,000 words, it doesn't really make sense to train a GPT-4 sized model with those 20,000 tokens. It will just memorize all of it and not generalize. The paper is referred here. The overall rule is that the number of parameters has to be proportional to the square root of the number of tokens. And if we take example from Llama 2, where 2 trillion tokens were available, and the largest model they trained was 70 billion parameters. If we scale it for the Estonian data that's available, which is 3 billion tokens, which is a web crawl of all of the data from 2021. This is all Estonian. I mean, not all of it is Estonian, but all of Estonian is in there. All of written Estonian is in those 3 billion tokens. This is 2 years old, so this week there was a data set called Culture X, I think, which includes 8.8 billion of tokens of Estonian and 145 other languages. But that still gives us, according to the Chinchilla law, 2.7 billion parameters. With the newer data set, it's something like 4.7. And supposedly the emergent abilities, so the actual, the thinking or how we define it, the task we didn't teach the model but it starts solving, those start after 7 billion and maybe even higher. So the current data for Estonian is just not enough. I have some little time to discuss the solutions which exist, for doing LLM stuff with Estonian. Solution one is naive. We don't do LLMs in Estonian or in Kihnu or in Võro or in Livonian. We just use machine translation, translate into English, process and translate back if the output is the written text. That has some benefits. So we don't need to train a new LLM, so this is cheap. And we reuse existing models. So that gets us up to some point. But first of all, it's not good for all tasks. Like if I want to take an Estonian sentence and check it for spelling mistakes or check it for grammatical mistakes or ask the model to explain to me where the mistakes are, this cannot be done through translation. I mean, it translates to English and all of the errors in Estonian input are lost. Same for other Estonian languages. Second thing is, machine translation, just like any other piece of AI, it doesn't work with 100% accuracy. It introduces errors sometimes, so it translates there and later back, and that adds errors into the process, so that hinders the performance. So, doable, but not perfect. Solution two, we train multilingual language models. This is how GPT-4 is done. This is how Bloom was done, but they failed to include Estonian. We train a huge multilingual large language model with Estonian data included. So we don't know exactly how much data GPT-4 included, but its performance is, better than nothing, but still leaves to wish for more. And I mean, the reason why this works is, of course, English has 800 billion, not 3 billion or 9 billion. Other languages have trillions of tokens altogether, and so their transfer learning happens, and so other languages learn from other languages, especially related languages. However, the minuses here are, this is really expensive. If we want to train a new language model, a modern one speaking Estonian and an open one and so on, this is really expensive. It's really hard to balance if we want to focus on Estonian to avoid it forgetting other languages. There isn't enough data for Estonian, and the related languages include Finnish. Let's be honest, Hungarian is related to Estonian just like other Indo-European languages are related between each other, like English and Armenian. So members of the same family, but not really close. So Hungarian and Estonian, they're grammatically related, but not really helpful in a model scenario. Only Finnish, and Finnish has maybe a couple of, 10 or 20 million tokens with Estonian. So let's say 2 or 3 times more. So this is extremely expensive, and it isn't bound to give us the cool results we want. Solution three, we take an existing model like Llama 2, like Falcon, like anything, and we fine-tune it to Estonian data, right? Because there's no point in training something from scratch when you can fine-tune, transfer the knowledge from the existing models, and I mean, this might work. First of all, still, it results, there's not enough data for it to learn in the cool way that it learns with English, German, Spanish, and French, and Arabic, and Russian. And secondly, it results in catastrophic forgetting. So we take Llama 2, we tune it to Estonian, and the model forgets everything it knew from the English data it has seen previously. So this is the effect that happens with fine-tuning where, you just teach the new stuff, and if you wanted to remember the previous stuff, you have to include the previous stuff in the data. And that gets expensive, and that brings us back to solution 2. Solution 3.1 is not fine-tune the model, but do instruction tuning. So reinforcement learning with human feedback, or LoRa for the low-resource scenarios to Estonian instructions. English model, like Llama 2, Estonian instructions. We take open source instruction data sets, machine translate them to Estonian, tune. The problem is we don't know if that works or not, because can you really teach a new language like that with instruction tuning to the model? Nobody knows. We'll find out soon enough. We're working on it. Solution 4 is generate more Estonian. Give birth to more kids and wait for them to write some more Estonian in the internet. But the faster one is actually to translate documents into Estonian. And we've already done it. We've generated something like 67 billion tokens for Estonian. So compared to the 200 million existing sentences, we've generated 4 billion sentences. That might allow us to train a language model with 13 billion parameters according to the chinchilla proportions. And we're still working on this. So is synthetic data better than including other languages? We don't know. We're checking. We'll come back to you. There are several other solutions which are even more crazy and explorative, and we don't know whether they will work, but the situation overall is that although Estonian NLP is a quite lively scene, there is no perfect solution for Estonian language and Estonian languages and large language models besides carefully prompting GPT-4. And that gets us quite far, but that's a close solution, and that's still not on the level of other languages that we would want to achieve. However, the point I try to make is that all languages and dialects deserve to be supported because there are people speaking them, and therefore we could support them, the languages and the people. And well, we, as in all of us, are working on it, so I guess stay tuned for more results. And this is it for me.
That was insightful. I must say I like the solution for the best. Not sure if we can generate Estonia, but maybe we can digitize more somehow. Because that's like, would be an easy way out.
Right. You could take radio broadcast and you can take TV and maybe transcribe speech.
That's actually a good idea.
Digitize more books. It's all expensive, but yeah, we'll do it anyway.
Do we have questions from the audience? Yes, we do.
Thank you. Great presentation. I really enjoyed it. One question. I want your opinion. I know there are no researchers on this, but it has been said that in the future, the languages of smaller countries are going to die out. Do you think that ChatGPT and LLMs are going to help that? Or do you think it's going to be the other way around?
I think they'll help preserve them, at least in digital form. Whether that will mean that people speak the languages, that's another question. I, however, don't believe that the small languages will die out. I mean, globalization is happening, but there were other examples in history where languages tried to die out and didn't. So Czech, I think, survived purely because a bunch of enthusiasts, which we could count on the fingers of one hand, in the 19th century revived it. And same for Livonian, which is now endangered or extinct, but it's being revived. Same for Yiddish, and there are several other examples. So, I mean, the dynamics of language development and the number of speakers is very complex. The languages keep changing under the influence of, well, everything and the globalization and so on. They'll definitely change. We shouldn't fight against that. But I don't think they'll die out completely. And the ChatGPT or the large language models, they'll at least preserve them digitally. At least I think the languages that are going to be supported with NLP have a much better chance of survival or of being relevant than the ones which are not. Hope it answers your question. Thanks.
More questions? I hope at least our dialects and, remain. Even if we all speak some Estonglish in the future, we still have our way of speaking.
Let's hope so.
More questions?
I missed some of the talk, so hopefully I haven't covered this, but are there any particular challenges when it comes to Estonian compared to other small languages with this MMLs?
That's the bigger part of the talk.
Right.
But yes, there are challenges. I mean, Estonian is a mid-resource language. It's not low resource, but it's not high resource, and its performance is better than it used to be, but still leaves to wish for better.